Okay, we are back. So this is Integrated 3. It's 10.2.1. It's your little lecture. This doesn't really go with a certain problem. What I'm trying to do, honestly, is I'm trying to give you this formula. I'm just trying to give you this formula. But if I just hand this to you and say, hey, this is the formula that you use if you want to sum up the terms in a geometric series, and I give you these A's and R's and stuff, you can plug numbers in. But okay, um, you wouldn't know what you're doing. So, I mean, you're just blindly plugging numbers in. So I'm going to try to show you where the formula comes from. That's what you would be spending your time doing in your teams. So I wrote out, so remember we were just looking as an example, we're just looking at these terms. 10 plus 50, it's multiplying by 5 every time. We know it has a rule. There's the rule. We know we can add it on a calculator and it gets 7,810. But what if I wanted to sum up the first 100 terms or the first 1,000 terms, or, I would need to find a way. Now, if you tried to do it like you would with arithmetic, it won't work. So maybe you haven't had a chance to try that. But you know how I was pairing them up when they're arithmetic? I'd say this plus this equals a certain number, and this plus this equals a certain number. And there's this many pairs, and I throw them in the formula. Well, I don't know if you can just see that by looking. That'll never work. So 6,250 plus 10 is 6,260. Well, 50 plus 1,250 is only 1,300. It's not going to work here. So they're asking you to find a way, like what can you do to figure out a way. Maybe you could like add it to itself or subtract it from itself or some kind of thing, and then supposed to figure that out in your teams. So I'm just going to kind of show you what you were supposed to come up with. What you were supposed to come up with is you write all the terms out, and then that's S of 5. That's the sum of the first 5 terms, and then you can subtract 5 times S sub 5 from it. Why 5 times S sub 5? Because it's multiplying. It's going up by 5 each time. So just kind of try to follow along what's happening here. 5 times all this. Well, actually, I'm going to say negative 5 because I want to kind of subtract. Negative 5 times this whole thing. I'd go negative 5 times this. Well, that's this, right? So notice I lined them up funny. I lined this up so that stuff will cancel out. Negative 5 times this gives this, right? Negative 5 times this gives this. Negative 5 times this. You'll notice the way that I lined them up, stuff's going to cancel out. But there's 1, 2, 3, 4. Negative 5 times this gives me this one. So this one doesn't have anybody to cancel out with. So I just end up with the first term and the last term, or the first term minus the last term, but it's not really the last term. Remember, this term is described by 10 times 5 to the n minus 1. So this is like, I guess, the one after the last term. Anyway, if this makes any sense, and then this can be S sub 5 minus 5 times S sub 5. So I've done all this, and then I'm going to factor out S sub 5 because these two terms both have a S sub 5 in them. So that gives me S sub 5 times 1 minus 5. Well, 1 minus 5 is 4, so I'm going to divide both sides by 4. Well, actually, 1 minus 5 is negative 4, so I divide both sides by negative 4. 10 minus this is this. Divide, ding, 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 I got the right answer. I got 7810 is what it adds up to on the calculator. So now I'm going to do it again with letters of the alphabet so that you could do it So you can use this method to get the sum of any geometric sequence. So now let's kind of think about what we did before. The sum of the first, maybe not the first 5 terms, but the sum of the first n terms. Well, you start out with the first term. A is the first term, right? Remember up here, A was the first term? Instead of the 0th term, A is the first term. And then it would be the first term times R. Because remember, we were multiplying, like, R was 5. And remember, we were going times 5 times 5. R is 5. So, like, the third term is actually the first term times 5 squared. And this is the first term times 5 cubed. And this is the first term times 5 to the 4th. Think about that. I'm going to use that right here. So every term goes up by whatever R is. So it'll be R. And then if you times it by R again, it's R squared, R cubed, blah, blah, blah. And the last term is R to the n minus 1. It's R to the n minus 1. So, like, if it was here, this would be R to the 4th. Because there's 5 terms, it would be R to the 4th. So that's why it's n minus 1. This is R to the n minus 1. And then the one after it would be R to the n. So this is how it looks. You go S sub n minus R times S sub n equals A. And then all these cancel out. And then this is negative A times R to the n. So basically, even if you don't understand how this is derived, when I do all this work, I get this formula. This is the formula. So this is the formula that gives me the sum of a geometric series. The sum of the terms of the first n terms. So A is the first term. R is the multiplier. And n is just like if you want the first 10 terms or the first 100 terms. N is the number of terms. Okay? I'll write that. N equals the number of terms. And so we can use this formula now. I'm sorry if you didn't understand the derivation of the formula, but now we have it. So we're going to do it. We're going to try to really quickly, I don't even know if I'll do the whole thing, but I'm going to start 10-91 with it. So 10-91, you're going to see a lot of these kinds of problems. It's about Scott and George, and they're looking for a summer job, and their father says, hey, why don't you pick up some trash, and I'll pay you 15 cents for each piece of trash. And Scott says, well, that doesn't make sense, because the more trash we pick up, the harder every time after we've been picking up trash for half an hour, it's going to be really hard to find pieces of trash. So he's saying, let's do it this way. How about if you give us 10 cents for the first piece of trash and then increase our pay by 2% for each piece after that? Then we'll get paid more for the pieces we work harder to find. So write an equation. So I always say y equals a times b to the x, but I want to remember I want a to be the first term, not the 0th term. So the first term, that's going to be 10. And then they're going to increase by 2%. So that would be 1.02. And then since I'm using the first term here, I need to go x minus 1. Okay. So this right here is our formula for just finding a term. And then, so I'm going to try to go quickly through this because I'm running out of time. But how much will his dad pay him for the 100th piece or the 200th piece? So for the 100th piece, well, I guess I'll just go y equals 0.10 times 1.02 to the 100th minus 1. So that's to the 99th, right? And then you can just, that's a 9. And then you can just put that in your calculator. I hope it works. Let's see. You go 1.02 raised to the 99th. Where's my 99th? And then times it by, oh, I did push the wrong button. Okay. 1.02 raised to the 99th equals that times 0.1. So about 71 cents. So he would get 71 cents for the 100th piece. And then I don't want to spend the time to put the 200. I just go 200 minus 1, and I do the same procedure for the 200th piece. And then let's see if we can just use our formula. I'm not going to have time to finish this whole thing, but let's try to use our formula to find out how much he would make if he picked up 200 pieces. Like, how much would he get altogether if he picked up 200 pieces? So let's get out our formula. What was it again? The sum of the 200 pieces. Oh, and the formula is on page, it's in a math notes box somewhere. Oh, boy. I lost where the math notes box. I had a page number for you for the math notes box. But anyway, I know that it is, there's my formula. So I know that it's, well, we'll just leave it right here. So A is the first term. So I'm going to go 0.1, because remember the first term was 10. And I'm going to go 1 minus R. R was 1.02 to the n, so to the 200, let's go like that, over 1 minus R. What was R? 1.02. And stick that all in my calculator. So 1.02 raised to the 200. See what that is. And then I'm kind of lazy. I know that's supposed to be negative, but I didn't bother pushing the negative thing. I think I can just know that that's negative. Okay, I know it's negative. I didn't feel like pushing the buttons in the right order. And then I'm going to divide it. 1 minus 1.02 would be negative 0.02. I'm just going to divide it by 0.02 because a negative divided by a negative is a positive. So I think he's going to get this much. 24 cents. Oh, check that. That seems like an awful lot of money. 91.